Hello viewers, hello students, welcome to our TU Education. I am Bilkis of your maths teacher. So today we will solve some question of exercise 15.1. Please support my TU Education and like and share my videos and subscribe my channel. Don't forget to hit the bell icon to get latest notification. But before solving question, I would suggest you to please watch the introductory video of probability, which is most important. The link is given below in the description box. So at first question number 1, probability of an event E plus probability of the event not E. Probability of an event E plus probability of the event not E is equal to 1. Again, I would suggest you please watch the introductory video, otherwise you will not understand anything. Probability plus E plus probability of not E is equal to 1. Next one, the probability of an event that cannot happen is 0. The probability of an event that cannot happen is 0. Such an event is called impossible event. Impossible event. Now next, the probability of an event that is certain to happen is 1. That means the probability of an event that is sure to happen is 1, and such an event is called sure event or certain event. Next, the sum of the probabilities of all the elementary events of an experiment is 4. Is equal to 1. The sum of probabilities of all the elementary events of an experiment is 1. That means, suppose in an experiment of tossing a coin, probability of head plus probability of tail is equal to 1. In an experiment of throwing a die, probability of 1 plus probability of 2 plus probability of 3 plus probability of 4 plus probability of 5 plus probability of 6 is equal to 1. That means all the elementary events of an experiment is 1. The next 5, the probability of an event is greater than or equal to 0. 5. Greater than or equal to 0 and less than or equal to 1. That means probability always greater than or equal to 0 or less than or equal to 1. Now next question number 2. Which of the following experiments have actually equally likely outcomes? Explain. So that means first question, a driver attempt to start a car. The car starts or does not start. So it is not an equally likely outcomes or equally likely event, because car will not start only when it is out of order. So next question. A driver attempt to start a car. The car starts or does not start. So it is not an equally likely outcomes. Because car will not start only only when it is out of order. Equally likely outcomes means, in this case, tossing a coin, probability of head is equal to half, and also probability of tail is equal to half. So in this case, probability head and probability of tail, these two events are equally likely events. But here, probability of start occur and probability of will not start occur, not both are same. That's why these are not equally likely outcomes. Now next, a player attempts to shoot a basketball. She or he shoots or misses the shot. So it is not an equally likely outcomes again, because this game depends on many other things or many factors. So it is next two. It is not an equally likely outcome because this game depends many factors. Next, 3. A trial is made to answer a true or false question. The answer is right or wrong. So it is an equally likely outcomes because answer is right, otherwise answer is wrong. So here probability of true and probability of false both are same. So that's why it is an equally likely outcomes. It is an equally likely outcomes because it is an equally likely outcomes because both have equal chance to happen. Equal chance to happen. Next, 4. So it is also an equally likely outcomes. So at first read the question number 4. Because question is a baby is born, it is a boy or a girl. So of course it is an equally likely outcomes. It is an equally likely outcomes or events. Now next question number 3. Why is tossing a coin considered to be a fair way of deciding which team should get the ball at the beginning of a football game? Why? Because the events head and tail both have the equal chance to happen. That means here head and tail are equally likely events. So both have equal chance. So question number 3. Because they have, or the event head and tail, the events head and tail both have equal chance to happen. Next question number 4. Which of the following cannot be the probability of an event? So you already know the probability of an event lie between 0 and 1. Question number 4. Probability of an event always lie between 0 and 1. So here first option is 2 upon 3. First option is 2 upon 3. So 2 upon 3 means 0.6 something. So that means this is lie between 0 and 1. And next option B, minus 1.5. So minus 1.5. So of course this is not a probability of an event because this is not lie between 0 and 1. Next 15%. Option C, 15%. 15% means 15 upon 100, 3 upon 20. So 0.1. That means this is always lie between 0 and 1, and 0.7 which is also lie between 0 and 1. So correct option is option B, which is negative value. Now next question, question number 5. If probability of E is equal to 0.05, question number 5, probability of E is equal to 0.05. And what is the probability of not E or E bar? We know you have to find the probability of not E. So we know that probability of E plus probability of not E is equal to 1. So that means probability of not E is equal to 1 minus probability of E. 1 minus probability of, that means 1 minus 0.05. 1 minus 0.05, that means 0.95. That's the answer. Now next question, question number 6. A bag contains lemon flavor candies only. Malini takes out one candy without looking into the bag. So what is the probability that she takes out an orange flavor candy, or second, a lemon flavor candy? So question number 6. A bag contains lemon flavor candies only. Flavored candies. A bag contains lemon flavored candies only. So there is no chance to occurring this event, that means orange flavored candy. So there is no chance to occurring, happen or occurring. No chance to occurring orange flavor this event. So a bag contains lemon flavor candies only. So there is no chance to occurring orange flavor candies. So that's why an orange flavor candies, what's the probability of an orange flavor candies? 0. And a lemon flavor candies, which is 1. That means first one is impossible event and second one is certain event. Probability of orange flavor candies, suppose we denote this O. So at first you write one line. Let O denote the event. O denote the would denote the event, and orange flavor candies. Orange flavored candies. And L denote L denoted or denoted the events and orange flavor candies, and L denoted the events. L denoted the event, a lemon flavor candy. A lemon flavored candy or candies. So that means probability of O is equal to 0, and second probability of L is equal to 1, because all the candies are lemon flavor in the back, so probability of L is equal to 1. Next question, question number 7. It is given that in a group of 3 students, the probability of 2 students not having the same birthday is 0.992. So what is the probability that 2 students have the same birthday? So very easy question. So we know that probability of E plus probability of not E is equal to 1. So given that the probability of 2 students not having the same birthday, that means probability of not E, given that this is equal to 0.992, and you have to find the probability that 2 students have the same birthday, that means probability of E. So this implies probability of A is equal to 1 minus probability of not E, that means 1 minus 0.992. 992, that means 0.008. That's the answer. Now next question, question number 8. A bag contains 3 red balls and 5 black balls. Question number 8. A bag contains 3 red balls and 5 black balls. Suppose this is a bag. 3 red balls and 5 black balls. A ball is drawn at random from the bag. What's the probability that the ball drawn is red or not red? So number of red balls 3, number of black balls 5. So total number of balls 5 plus 3, 8. So at first write number of red balls 3, number of black balls 5. So total number of balls 8. So that means probability of red ball so what's the formula? Total number of balls which is 8, and number of red balls, probability of red balls, so number of red balls, that means 3, so 3 upon 8, because probability of any event is equal to number of ways an event occur upon total number of outcomes. So here total number of outcomes 8 and number of ways an event occur, which is 3. And next, probability of not red, which is 1 minus probability of red ball. So that means 1 minus 3 upon 8. 8 minus 3, So 5 upon 8. That's the answer. Now next question, question number 9. A box contains 5 red marbles, 8 white marbles and 4 green marbles. Question number 9. Suppose this is a bag. A bag, only one box contains 5 red marbles, 8 white marbles and 4 green marbles. One marble is taken out of the box at random. What is the probability that the marble taken out will be red, white and not green? So here again number of red marbles, number of red marbles is equal to 5, number of white marbles is equal to 8 and number of green marbles is equal to 4. So total number of outcomes or total number of marbles is equal to 5 plus 8 plus 4. 5 4 9, 9 plus 8 17. Now you have to find the probability of red. So same probability of red is equal to number of ways an event occur upon total number of outcomes. Total number of outcomes 17 and number of ways an event occur, that means 5. So probability of white is equal to similarly 8 upon 17 and third probability of not green, that means 1 minus probability of green. So 1 minus probability of green, which is 4 upon 17. 17 minus 4, that means 13 upon 17. That's the answer. So today's class ends here. Next day we will solve the other questions. Thank you.